You know, when you log into some website using your Google account, or maybe let an app access your photos, but you don't give it your actual Google password.
That happens all the time.
Right. That connection, that secure link. Well, that's often OAuth 2.0 doing its thing behind the scenes.
Exactly. It's like this invisible framework that makes a lot of the modern web work securely.
So today on the deep dive, we're going to unpack that, OAuth 2.0.
Mm-hmm.
Our goal is pretty simple. Break it down so it's clear how it works, why it's so important for security online, without getting totally lost in the jargon.
Sounds good. Yeah, we've got some solid sources that explain it well, and we'll try to make sense of it all. It's fundamental stuff.
Okay, let's just jump right in then. What is OAuth 2.0, at its core?
Okay, so OAuth 2.0 stands for Open Authorization version 2.0. It's basically a security standard. It came about officially around 2012, defined in these documents called RFCs, specifically 6749 and 6750.
Right, the technical specs.
Oh.
But what's the big idea?
The really big idea, the breakthrough, was creating a standard way for, say, an application to get access to your stuff, your data, hosted somewhere else, without you having to give that application your password for the other service.
So it avoids handing out my main password everywhere.
Precisely. It's all about delegated access. The sources use a great analogy. Think of giving a valet your car key.
Okay.
They can park the car, right? They have the access they need for that specific job, but you didn't give them your house keys or, the keys to your entire life.
Gotcha. Limited access for a specific purpose.
Exactly. OAuth 2.0 works on that same principle. It lets you grant limited specific permissions to an app, and importantly, you can usually revoke those permissions later. It's a huge step up from the old days of sharing passwords.
That valet analogy really clicks. Makes sense.
Yeah.
So who are the main actors in this whole process?
Yeah, there are 4 key roles you need to understand in any OAuth 2.0 flow. First up is the resource owner.
And that's me, the user.
That's usually you, yeah. The person who owns the data that the application wants to access, your photos, your calendar, your contacts, whatever it might be.
Okay, I'm the resource owner. Who's next?
Then you have the client. This is the application that wants to get access to your data.
Like Spotify wanting to see my Google Calendar?
Perfect example. Yes, Spotify is the client in that scenario. It wants permission to look at your calendar data, maybe to suggest playlists or something.
Right. And my calendar data itself, where does that live?
That's on the resource server. This is the server, or the API, that actually stores and protects your data. So in the Spotify example, Google's calendar API servers would be the resource server.
Okay. Owner, client, resource server.
What's the last one? The final piece is the authorization server. This is the really critical one for the security flow. It's the server that handles, authenticating you, making sure you are who you say you are, usually via login.
So it checks my password, for instance.
Yes, it handles that login process securely. And then, crucially, after you grant permission, it's the authorization server that issues the special digital keys called tokens, which the client needs.
Tokens. We'll need to talk more about those.
Definitely. But those 4 roles, resource owner, client, resource server, authorization server, they all work together in this coordinated dance to make sure access is granted securely.
A system of trust and permissions, basically.
That's a great way to put it. Now, to see how they interact, we should probably walk through the most common method, which is called the Authorization Code Flow.
Authorization Code Flow, right? You said it's the most common.
Yes, and generally the most secure, especially for things like websites and mobile apps that users interact with directly.
Okay, so how does that work, step by step?
All right, so step 1. The client application, let's stick with Spotify wanting calendar access, redirects you, the resource owner, over to the authorization server.
Which would be Google's login page in this case.
Exactly. You land on that familiar Google page. Step 2. You log in there securely with your Google credentials. Google's authorization server confirms it's you. Then it asks if you're okay giving Spotify permission to access, say, your calendar data.
And I'd see a screen saying, Spotify wants to view your calendar, maybe?
Precisely. You review the permissions, requested the scopes, and if you agree, you click Allow or Grant.
Okay, I clicked Allow. What happens next? Does Spotify get my data now?
Not directly. This is key. Step 3. The authorization server, Google, doesn't send your data or even a long-term key back to Spotify immediately. Instead, it sends your browser back to Spotify, but with a special temporary authorization code attached.
An authorization code is a temporary thing.
Right. It's short-lived, single-use. Think of it like a claim ticket. Step 4. Now, Spotify, the client, takes that authorization code. It then communicates directly and securely, server to server, with Google's authorization server again.
Oh, behind the scenes this time.
Yes, without you directly involved, Spotify basically says, hey, I have this authorization code the user just approved. It presents the code and potentially proves its own identity too. If everything checks out, the authorization server then gives Spotify the actual access token.
Okay, that's the real key it needs.
That's the key. And sometimes it gets a refresh token too, but let's stick with the access token for now. Step 5. Spotify, the client, now uses that access token to make requests directly to the resource server Google's Calendar API.
So now it can ask for my calendar events.
Exactly. It presents the access token with its request, like showing a valid badge. The resource server checks the token, sees it's valid and has the right permissions, and then provides the requested calendar data back to Spotify.
And the most important part you said is that Spotify never saw my Google password.
Never. That's the fundamental security benefit. Your main credentials stay only with the authorization server, Google in this case. The client application just gets these temporary limited scope tokens.
That whole flow makes a lot more sense when you break it down like that. Okay, you mentioned tokens a few times. Let's get into those. Access token, refresh token. What's the difference?
Right, tokens are central to how OAuth 2.0 works. There are a few main types. First, the access token. As we saw, this is what the client uses to actually call the API to access your protected resources.
The key to the data door.
Kind of, yeah. But a key feature is that they're usually short-lived, maybe valid for an hour or even just minutes.
Why so short?
Security. If an access token somehow gets leaked or stolen, the potential window for misuse is very limited because it expires quickly.
Makes sense. Minimize the damage. So what about the refresh token? You said Spotify might get one of those too.
Right. The refresh token is different. It's typically much longer-lived days, weeks, maybe even months. Its only job is to get new access tokens.
So when the short-lived access token expires.
Exactly. Instead of bothering you, the user, to log in all over again, the client can use the refresh token, which it's stored securely, to go back to the authorization server and say, my access token expired. Here's my valid refresh token. Can I have a new access token?
And the authorization server gives it a fresh, short-lived access token.
Correct. As long as the refresh token is still valid and hasn't been revoked, this allows apps to maintain access over time without constantly asking you to re-authenticate. It's why you stay logged into connected apps.
Okay, that explains a lot. Access token for the actual work, refresh token to get new access tokens silently. Is there anything else?
There's one more type often mentioned, the ID token. Now, this is technically part of OpenID Connect, which is like a layer built on top of OAuth 2.0, specifically for authentication, proving who the user is.
So OAuth is about authorization, what you can do, and OpenID Connect is about authentication, who you are.
You got it. And the ID token is the proof of authentication. It's usually a digitally signed blob of data, often in a format called JWT, JSON Web Token, that contains information about the user, like their user ID, maybe email when they logged in. The client application can verify this signature to trust the information about your identity.
Interesting. So different tokens for different jobs in this whole security dance.
Precisely. Now, OAuth 2.0 is also flexible. It acknowledges that not all applications work the same way. So it defines different methods or grant types for how a client can obtain that initial authorization code or access token.
Grant types. Okay. We've mostly talked about the authorization code one.
Yes, the authorization code grant type, often with PKCE, which we should touch on later, is the gold standard for web apps and mobile apps where a user is present. But there are others.
Like what?
Well, there's the client credentials grant. This is designed purely for machine-to-machine communication. Think server to server. There's no user directly involved clicking allow. One backend service needs to securely access another service's API.
So no browser redirects or user login prompts for that one.
Right. The client authenticates itself directly using its own credentials. Then there's the refresh token grant, which isn't really about initial authorization, but it's the process we just discussed using a refresh token to get a new access token.
Okay, that fits. Any others?
One more common one is the device code grant. This is tailored for devices that don't have easy input methods, like smart TVs, game consoles, IoT gadgets.
Oh yeah, where typing a password is a nightmare.
Exactly. With this flow, the device usually shows you a short code and tells you to go to a website on your phone or computer. You log in there, enter the code, and grant permission. Then the device pulls the authorization server until it gets the tokens.
I've definitely done that setting up streaming apps on my TV. So OAuth has different tools for different client types.
It does. But no matter which grant type you use, security is absolutely non-negotiable. The sources really hammer this home. There are several critical security measures that must be in place.
Okay, let's talk security must-haves. What are the absolute basics?
It's top of the list. HTTPS everywhere. All communication in an OAuth flow, redirects, token exchanges, API calls must happen over encrypted HTTPS connections, no exceptions.
Encrypt everything. Got it. What else?
For mobile apps and single-page web apps, basically, clients running in less controlled environments using PKCE is crucial. It stands for Proof Key for Code Exchange.
PKCE. Sounds technical. What does it prevent?
It prevents a nasty attack where a malicious app on the same device could potentially intercept that authorization code we talked about earlier as it's being sent back to the legitimate app. PKCE adds an extra verification step using a secret generated by the client to make sure the app starting the process is the same one exchanging the code for a token.
Ah, so it stops code hijacking on my phone. Important.
Very. Next up, using state parameters. When the client first redirects the user to the authorization server, it should include a unique, unpredictable state value. The authorization server must then include that exact same value when redirecting the user back.
Why? What does that check?
It protects against cross-site request forgery or CSRF attacks. It ensures the response coming back actually corresponds to the request your application initiated and isn't triggered by some attacker tricking your browser.
Okay. Verify the round trip. Makes sense. More security points.
Absolutely. You must validate tokens. When a client or resource server receives a token, like an access token or ID token, it needs to check that it's legitimate, that it was issued by the correct authorization server, hasn't expired, hasn't been tampered with, and is intended for the right audience.
Don't just trust the token, verify it.
Exactly. And related to that, secure token storage is vital. Clients shouldn't just stash tokens in insecure places. They need proper protection, often encryption, especially for refresh tokens, which are longer lived.
Right. Treat them like sensitive credentials.
They are. And finally, the principle of least privilege, enforced through scopes. When an application asks for permission, it should only request the minimum set of permissions, scopes. It absolutely needs to do its job. Don't ask for full account access if you only need to read calendar events.
Only ask for what you need. Seems like common sense, but crucial for privacy.
Absolutely. So those are the big security requirements. Now, if you're actually building something using OAuth 2.0, there are some key best practices our sources recommend.
Okay, practical advice for developers. What should they keep top of mind?
Probably the single biggest piece of advice is don't roll your own OAuth 2.0 implementation. Use well-established, vetted libraries.
Don't reinvent the wheel, especially the security-critical wheel.
Precisely. There are excellent libraries out there for most platforms, things like Spring Security OAuth 2 for Java, Authors SDKs, Passport.js for Node, and many others. These have been battle-tested and handle many of the security nuances correctly. Building it yourself from scratch is incredibly risky and prone to subtle, dangerous flaws.
Okay, use the standard libraries. What else?
Secure token storage, as we mentioned. Really think about where and how you're storing tokens, especially refresh tokens. Use encryption. Also set sensible token lifespans.
We talked about that short access tokens, longer, but not infinite refresh tokens.
Right. Finding the right balance between security and user experience is key. Shorter access tokens limit risk. Appropriate refresh token lifetimes. Avoid making users log in constantly, but still manage session length.
Good balance. Anything else for developers?
Yeah, consider using tools for security-focused code reviews. The sources mention CodeRabbit as an example. Tools like that can help automatically spot potential security issues in your implementation before they cause problems.
Proactive checks. Smart.
And finally, conduct regular security audits. Have experts review your implementation periodically. The landscape changes, new vulnerabilities are found, so you need ongoing vigilance to keep user data safe.
Makes sense. It's not a one-and-done thing.
Definitely not.
Okay, so let's try to wrap this up. OAuth 2.0. It's this really vital security framework that makes a lot of the modern web tick. It lets apps talk to each other securely on our behalf, crucially without us spreading our main passwords around.
That's the core of it.
It involves these four players: the user, the app, the data server, the login server, working together using different kinds of tokens and different flows depending on the situation.
The Authorization Code Flow being the main one for users.
And security isn't optional, it's built in with things like each there's token validation and scopes being essential.
Absolutely critical layers of defense.
And for anyone building this stuff, the message is clear. Use trusted libraries, store tokens securely, manage their lifespans, review your code, and get audited.
That sums it up well. And the real benefit, as we've discussed, is this neat separation of authentication, who you are, from authorization, what you're allowed to access. That separation is key for user privacy and enables much safer data sharing online.
It really does give you a different perspective the next time you hit that login with Google or connect with Facebook button. You realize there's this whole carefully orchestrated security process kicking off.
Exactly. It's working hard behind the scenes. And maybe that leaves us with a final thought, like thinking about data privacy, user control. How fundamental are frameworks like OAuth 2.0 in giving us that control in this super connected world?
Yeah.
And looking forward, what other pieces of the online security puzzle might become just as essential, just as foundational as OAuth 2.0 seems to be today in shaping how we interact securely online and protect our information down the road?
That's a really interesting question to ponder. What's the next OAuth 2.0 or what complements it in the future? Definitely something to think about.